Hello all, in this video we'll be learning about fourth unit of CNC technology, which is nothing but NC programming and computer part programming. So first NC part programming, manual programming basics we have to learn. Next what is meant by point to point and countering program we have to learn. CAN cycle, how the CAN cycles are implemented. Next parametric programming, what is meant by parametric programming, etc. And coming to the computer part programming, you have to know the general information like ATP programming, any examples of ATP programming. And here we will be learning only one 2D machining only. Next CNC programming, how to make CNC programming on CAD/CAM systems. Design and implementation of post processor. After the manufacturing completed, what are the design and implementation we have to implement. Next, introduction to CAD/CAM software, different CAD/CAM softwares. Next, by using this CAD/CAM software, generating the automatic toolpath generation. So manual programming. So first we have to know what is meant by CNC coordinate system. So if I say the coordinate system, then this is the coordinate system for drilling machine, and this is the coordinate system for milling and milling can be considered for milling and drilling purpose. So in the for drilling purpose, this is my x-axis, this is my y-axis. This direction, this distance is x-axis and this distance is y-axis, and this distance coming down is the z-axis. Similarly, so from the origin, positive x, negative x, next positive y, negative y, then comes as positive z and negative z. So this is a coordinate system. So z-axis is mainly perpendicular to the workpiece. So workpiece is xy direction and z-axis is perpendicular to the workpiece, so that we can make any drilling of the holes, etc. And next, for lathe machine, if you see the CNC turning machine or lathe machine, so for the workpiece, this direction is positive x and this direction is negative x, and this direction is positive z and this direction is negative z. So this is a machine tool axis system. So if you take for the turning operation or lathe machine operation, we'll keep the cylindrical objects generally, and this side will be positive x and this will be positive z, and back side will be negative z, and if you move from this side it will be negative x. So these are the different coordinates we consider for turning machine. Next, classification. So first classification, according to the type of machine used, we use two types: point to point and straight cut, and continuous path. And according to the programming method, we use absolute programming, incremental programming, and according to type of control system, we use open loop control system and closed loop control system. So these things we'll be learning. So these things we'll be learning in this topic. So first is point to point. So point to point is nothing but just it is used for drilling purpose. So the cutting tool will be at the home position. It will come to the required position. Suppose this is like 5 comma 5 and 25 comma 5 and like 25 comma 25, and this is 5 comma 25. So if these are the coordinates, so first from the home position you'll go to the first drill position, then you'll come to the second drill position, then third drill position, fourth drill position. When it comes to the drill position, then the spindle will move, and this vertical movement will be applied, then it will move inside, and it has to, suppose this is the cutting position, the cutting tool has to come outside of the workpiece, then it will go up, again it will go to next position, again come down out of the workpiece, then again above, then last position, then out of the workpiece, it will come out of the workpiece, then it will go to the home position. So this is the top view and this is the front view, how the cutting tool moves from one place to other. So it will moves in point by point operation, it will moves. Next, straight cut. So it will move in a straight path. So in one axis, either x axis or y axis, it will move. So this is the top view. This is our cutter or cutting tool. And in this one, from the home position, the cutter will move in x direction, then y direction, x direction, then y direction, then again it will come back to home position. So it can move only parallel to either x or y in the straight cuts. Coming to continuous path, in this continuous path, if we have any radius, it has to travel. Instead of going in x and y, it has to go any radius. Then we use this contouring NC mode. Okay. So it has the combination of both straight cut and circular interpolation, and again straight cut. It will move in those fashion. It is a combination of straight cut and circular interpolation. Both it will move. So it is helpful for milling, grinding, and lathe operation. It is helpful. Next, coming to the another classification, according to program method, there are two methods. Either we can set by using absolute method or incremental method. So here I will be explaining. So these are the coordinates where the workpiece has to move. And when we are writing program, how we have to write when we are writing for incremental and how we write for absolute. So for the absolute, everything with respect to the origin. For absolute, everything we take with respect to origin. So x-axis from the origin, x-axis has moved 1 mm and y-axis move 1 mm. From the origin, x-axis has moved 3 mm and y-axis has moved 3 mm. Coming to absolute. So on in the absolute, x-axis has moved 6 mm and y-axis has moved 6 mm in the absolute. But coming to incremental, so initial will be 0. The initial point will be 0. This is the 0th point. This is the first point. For the first point, previous point will be 0. For the second coordinate, first coordinate will be 0. And for the third coordinate, second coordinate will be 0. So if I want to go here, it will be 0. So from 0, it has gone 1, x-axis 1, y-axis 1. And for this 1, 2, and 3, when I want to go from 1 to 2, so for the second position, first position coordinate will be 0 comma 0. So from here it is 0, then it will move 2 in x-axis and 2 in y-axis. Then only it will go to second point coordinate. When we want to go to third point, then this coordinate will be 0 comma 0. So from here 0 comma 0, x has to move 3 mm and y has to move 3 mm. That is the difference between absolute and incremental system. So in absolute we have fixed origin, and in the incremental it is reference to the previous two location, and previous two location will be 0 comma 0, and it will be in the form of incremental. So if you say take here 3 minus 1, then here the value comes as 2. If you take here 6 minus 3, then here the value comes as 3. If you take here 1 minus 0, so value comes as 1. Same way we follow in this case. So this is the difference between absolute and incremental system. Next, advantages of absolute. So in case of any stopping or any interruption, suddenly power cut or any other thing, then we can return to previous position easily, and we can start easily if you are using absolute. And one more is, so we can change the dimensional data easily, because all the coordinates are with respect to origin, so we can change the dimension coordinates easily, we can modify easily, and we can describe the counters and positions easily to understand. So no need of adding, subtracting anything. Directly we can know the absolute dimensions with respect to the first dimension we take, or else from the origin we can calculate easily. Next, advantage of incremental programming. So sometimes absolute will be messy. Why? Because here for each axis we are making separately, commands are given separately, and if you add everything, they the value must be 0, and non-zero sum indicates that you have some error in your program. Okay, so like that, if you want to find your errors, then you can go with the incremental programming. Next, so if you are using this one, it is checked by a closed loop tape, and commands on the tape will be returned to its initial position. So after completed, it will return to its original position. And if you are making any mirror programming, in the mirror programming, suppose if you are making any butterfly like this, if you are making any butterfly shape, example I am saying, if you are making any butterfly shape example, so this we will divide into 4 equal parts, and we draw only one part. we write the programming only for one part, and all the other we make using the mirror image. So if you are making any mirror image programming, then it will be helpful. This incremental programming will be helpful. And incremental dimensioning programming is advantage for individual part counters. So if any you are drawing any individual parts and you are repeating it continuously and without any corner shifts, without any change of the axis or dimension, then if you want to continue, then you can use this incremental programming. Next, classification. So based on the feedback system, open loop and closed loop. In the open loop, what we do, whatever the movement tool movement is there, that is given by drive motor, and MCU will give all the instructions. This MCU will give the instructions to drive motor. This drive motor will help the cutting tool to move forward and backward. Okay, so this is the open loop diagram. Next is the closed loop. In the closed loop, we have a feedback device. So MCU will give all the instructions. So velocity, MCU give the instruction to the different like tacho generator it has given. So this tacho generator or driving will give to the slide, and we have a measuring device how much it is moving front and back. So this measuring device will give displacement feedback to this one, and this tacho generator will measure the how much is the speed or velocity, and this velocity is given to MCU. And if there are any errors, what it will do, it will again change its instructions. Whatever the instruction is given to drive unit, it will change the instruction and it will modify. So this is the difference between open loop and closed loop control system. Next, part programming. So whenever you are learning CNC technology, compulsory you have to learn the part programming. So it involves the following. So first is you have to know the part programming fundamentals. So in the part from programming fundamentals, we have to know whether you are giving XYZ or any of the other coordinates in this one. So first thing is we have to study the component. So whatever we are manufacturing, first we have to know the drawing of the component. Then we have to identify the machine tool, whether we are using the CNC milling machine or CNC lathe machine or CNC drilling machine. We have to identify. Then we have to select the cutting tool. So which type of cutting tool? Suppose we have to make a drill of 10 mm. So which type of cutting tool we have to take, whether the drill bit or any other thing, that we'll check in this one. Next, we have to determine machining parameters. How much is the speed, feed, depth of cut, everything we have to take. So this machine tool is available in the machine tool database. So already we buy the tools. That data, from that data we'll select the machine, which type of machine tool, and which type of cutting tools we have to select. We'll select by machine tool database, and which machine parameters is suitable for your machine. That also will check by using this one. And then it will send to the prepare job and tool setup plans. So we'll prepare a job, we'll take the job dimensions and everything, and we'll set up tool plans, which type of tools, everything, how much, how we have to start, we'll write. Then we will write the part program and we'll test the part program, and if it's success, then only we'll send it to the machine control unit. If there is any wrong in the test part program, again we'll go to determine the machine parameter. Are there any default errors in the machine parameters, or we have not prepared the job well, or in the program there are any errors or not? Again we'll check, again we'll send. After sending to machine control unit, and we'll check the driving systems, we'll check the slides movement, we'll check the cutting tool, everything, and then we will inspect the part. So last portion is inspecting the part. Then after everything is correct, then we will save it as a document or will store in the storage system. So first we have to prepare the process plan. Next we have to identify the machine tool, same thing. Then we have to final stage of the part programming, we have to document everything. So there are different codings. So these are A, B, C, D, E, F till M. Yeah, coding. So you can learn this automatically. Nothing much explanation in these alphabets. They mean nothing but miscellaneous function. Generally we don't use L. So all we know that A, B, C. So it is A is the angular dimension of X, B is the angular dimension of Y, C is the angular dimension of Z. And coming to DE, if you have any 4 axis, 5 axis or 6 axis, then we can assign for DE. F comes as feed function. So what is the feed input feed we are giving? G is nothing but G codes or preparatory function. H is not assigned, and IJK are used when we are using any arc, like any radius we are using or any thread we are making. That thread should be parallel to XYZ. At that time we use IJK. So I will be with respect to X, J with respect to Y, and K with respect to Z. Okay. So these are the different letters we use. Next, N to Z. N to Z. N is nothing but sequence number. O is a reference or a rewind or stop. PQR. PQR comes as third rapid transfer, second rapid transfer, and first rapid traverse movement. And S is nothing but spindle speed. T is nothing but tool function, and UVW. If you are unable to use XYZ, then we can use like UVW. We can use, if you are unable to use XYZ in the program, already you have given XYZ and you have created a loop and you have to give again XYZ. You are not interested to go again XYZ, then we can use UVW. And XYZ comes as primary motion, X direction, Y direction, and Z direction. And next, part programming. So there are some sequence which we have to follow. This sequence can be asked in the exam. First is N, G, XYZ is complete one, then F, S, T, M, then EOB is one part. So what is meant by N, G, XYZ? We'll learn. N is nothing but sequence number. So when we are writing, we have to give a number. So example, like if you have your laptop and you have a number of files, so you'll give the files with respect to numbers like 1 2 3 4 5, or as per the dates you have some sequence number. Next, preparatory function. So G codes, without G codes the program will not start, and you can write either XYZ, ABCDE, IJK, UVW, because this is called dimensional data. So here in the third format you have to give the dimension data. Next, F is nothing but feed function. S is nothing but speed function. Next, T is nothing but the tool function. Suppose if you want to change the tool from 1 to 12, so you'll write that M12, M06 12, you will write T12, you will write. M is nothing but miscellaneous function. EOP is nothing but end of the block. So this is the format you have to learn. NG, dimensional data, feed, speed, tool, miscellaneous function, and end of the block. This is the format we follow while writing the part programming. Next, basic input data. So it is as this. All these are the different. The sequence number is called encode. Preparatory function are called G code. Coordinate functions are XYZ, ABC, IJK, UVW. These are. Feed function is represented by F, speed function S, tool function by T, miscellaneous function by M code, end of the block by EOB. So this is the format we follow. N001. So first sequence number will give, we have to give N001. G01 is the preparatory code. If you are giving XYZ, X is 25 mm, Y is 25 mm, Z is 10 mm, positive Z is 10 mm, and feed we are taking as 100 mm, and speed we are taking as 600 rpm, and here we have selected the tool number as fourth tool number, and here we are using M code or miscellaneous function code as M06, then end of the block. So this is the basic CNC input data. By this one you have to write the programming. So coming to the sequence number, so we start sequence number. Generally we assign sequence number starts from N000 to N9999. So total up to maximum 4 digits we can write the sequence number. And generally when we are writing, you shouldn't write like N01, N02 continuously. You shouldn't write. Generally we write in N10, N20, N30. Why we write like this? So that if we have done any mistake, so that we can insert 9 new terms inside. Suppose I missed something, then I can write that N10, N15, N20, N30. Then I can follow. If I miss any of the code, line of the code between N10 and 20, then I can move forward by using this one. So example N025, Y25, and Z0. So preparatory function, these are called the G codes. It is start with the letter G. So it is a preset function. So these are the preset functions or preparatory functions already available for the machine access. Okay, so we cannot use in one line, we cannot use more than one d, like g example, g02 and g03 we cannot use together because g02 is rotating clockwise anti-clockwise. So in a single line a tool cannot rotate in clockwise one time and anti-clockwise one time. So is not allowed to write more than one g code in one single line. Better to write two g codes in. And coordinate function xyz uvw ijk, all these are coordinate function. Example, x is 100.125, y is minus 25.005, z is minus 5.565. So like this we will have a different preparatory functions, coordinate functions, etc. So these preparatory functions are again each, it will start from g00 to g99. So here till G19, so G00 rapid traverse, G01 linear interpolation, G02 circular interpolation, G03 circular interpolation. Interpolation clockwise and counterclockwise. Rapid traverse, it will go to home position and positioning, then we use G00. If it has to move in linear x axis, y axis or z axis, we use this one. When it has to move in xy direction, yz direction, zx direction, then we use clockwise or anti-clockwise. Dual, it will stop sometimes, G05 hold or delay, then G06 parabolic interpolation. If it has to rotate in parabolic, then we use parabolic interpolation. G08 acceleration of feed rate. Suppose we are given the feed rate as 100 mm. Suppose in that one we want to increase the acceleration, then we can use G08. And if you want to reduce the acceleration, we can use G09. And G10 linear interpolation, same G01, but it is used for longer dimension, 10 inches to 100 inches. And G11 linear interpolation for shorter dimension we can use. And G12 is unassigned. G13 to 16 is axis designation, like x axis, y axis, z axis. If you want to determine, we can use this one. G17 xy plane, so xy plane, y zx plane, and G19 comes as yz plane. Okay. So these are the different G to G19. From into G20 to G61. So G20 circular interpolation for longer dimension, circular interpolation for shorter dimension, circular interpolation counterclockwise, counterclockwise longer and shorter. If you want to make any thread cut, we use G33. G34 is used for the thread cutting when we are making the increasing the lead. G35 for decreasing the lead. When we are making thread cutting, we have to maintain constant lead. That will be taken care by this one. Next, G40 cutter compensation will be 0. So cutter compensation, everything will be learned in the next topics. G41 cutter radius compensation offset to the left side. The radius compensation should be on the left side. Radius compensation is on right side. G43 radius compensation is positive. Radius compensation is negative. Like G53 deletion of zero offset. If you have created a zero offset, it will be deleted. For 54 to 59, we can fix our datum point or shift zero shift point we can create. G60 we have to make the target value position tolerance as 0, and G61 target value or loop cycle we can create by using G61. And coming to G63 to G99, so G63 is a tapping cycle. If you want to make any internal threads, we use G63. G64 changing feed rate or speed, both we can change by using G64. And G70 when we want to give the dimensions in inch units, and G70 metric units, because some countries use inch system, some countries use metric system. In India we use metric system, but in Britain or any European countries, most of the European countries will use inch system. Next, G80 candle cycle is cancel, and G81 to 89 there are different candle cycle from drilling to boring, etc. And G90, if you are giving absolute incremental or absolute dimensioning, then we use G90. If you are using incremental, then we use G91. G92 program reference point shift, so we are shifting the reference point by using this G92. And G94, if you want to give feed rate per minute, what are the feed we are giving, the feed rate should be in minute, then we'll give this one. And feed rate will be as per revolution. If you want to give, then we use G95. And if you want to maintain the feed rate at constant surface speed and revolution per minute, then we'll use this G96 and 97. And coming to G99, it is unassigned. G98 and 99 is unassigned. Next, feed functions. So in this feed rate for displacement or spindle feed rate is expressed in mm per minute or per revolution. So it is 3 digits code we can give, like F01, F30, F300, F600 we can give. And coming to speed function, it is represented by S. It is given in revolution per minute or RPM or RPS. So S 1000 indicates that we are giving in 1000 RPM. Next, tool change. If you want to change any tool, we use T05 M06. So initially we have tool number, example we have tool number 3. We have to change from tool number 3 to tool number 6, tool number 5. Then we give tool tool 05 and M06. Then automatically the tool will be changed. Next, miscellaneous functions. So nothing but M code. These are the machine codes without which the machine will not start or stop. So M1 to M6. So M01 programs, M00 program stop, M01 optional stop. We can stop and we can resume later. M02 end of the program. When it comes to end of the program, it will start. And M03 spindle will rotate clockwise. M04 spindle rotate in counterclockwise or anti-clockwise. M05 spindle will be off. M06 tool will be changed. Completely the tool will be changed. Next, M06 to M99. M06 is nothing but the tool change. M07 is coolant, second coolant will be on. M08 will be coolant number 1 will be on. M09 coolant will be off. M10 we can clamp the workpiece, we can unclamp the workpiece by 11. And in 13 spindle rotate clockwise and coolant will on simultaneously. In M14 spindle rotate anti-clockwise and coolant will be on. M15 motion we can increase the motion, and M16 we can reduce the motion. M30 end of the tape and tape prevent. So this is used for NC machine. Nowadays in CNC machine we are not using any tape, but still we write M30. M11 interlock bypass. If there is any lock suddenly, then it will bypass the lock. And if you want to maintain constant speed, then M32 to 35. And if you want to change the gears in the NC, then M40 to 45. And if it depends upon machine to machine, it will depends what we are using. Reverse for uncontrolled use. And M50 to M99 it is unassigned. Next, interpolation. So we are talking about interpolation like linear interpolation, circular interpolation, and parabolic interpolation that we'll learn here. So first is linear interpolation. The shortcut is G01. If you write G01, it will move in linear interpolation like x-axis, y-axis. So in this case, my tool has to move from A to B. Then what is the interpolation? If my tool has to move from B to A, then what is the interpolation we have to use? But here it will move in whether absolute it will move or incremental it will move, depends what is the distance you have to write by using in this interpolation. So for absolute programming, now my point is moving from A to B. This is my initial stage, first stage, then I go to second stage. So in this case, so this distance it will cover x-axis from here to here, it has to move 160 mm, and y-axis it is negative minus, it will go. So it will directly check the final coordinate system in the absolute programming. So 160, this coordinate system is 160 comma 40. X-axis will be 160, y-axis will be 40. So sequence number will give G90 is the shortcut for absolute. G01 is linear interpolation. X-axis it has to go to final position as x160, y40, and feed we given at the rate of 200 mm per minute or mm per revolution. And coming to the incremental we are moving from A to B. Then we have to subtract x2 minus x1, y2 minus y1. If we do x2 minus x1, 160 minus 160 minus 30, then this distance comes as 130 only. So it has to move 130 in x-axis and y2 minus y1. Y2 is 40. 40 minus 150. So it has to go down minus 110. Okay. Then feed is same. So same thing for absolute and incremental. So circular interpolation. So as the name suggests, it will move in the circular fashion. Whether you are going from A to B or B to A, it matters. And whether you are going for clockwise movement, then you are going from A to B. If you are going counterclockwise, then you will go from B to A. So in first case example, we have to move from A to B. Then how we have to write code is circular interpolation is clockwise is 0 G02, anti-clockwise is G03. So here in this one, so N0 sequence number we are giving G02 is circular interpolation, and we have to how much what is the final coordinate. So x-axis is 60. So final coordinate is x will be 60, 60 comma, and y-axis is 70. So this coordinate is x is 60, y is 70. So x is 60, y is 70, and we have to specify the radius from where it is taking the radius. So this radius is 40. So from we have to give radius 40 and f 200. And coming to same to the when we are moving from B to A, so we have to know the A coordinate system. So A coordinate is x axis is 20 and y axis comes as 40. So here we'll write N04 counterclockwise. Z03 is counter. So from B to A, our initial position is here. Our cutting tool is here. From here it has to move. So X is 20, Y is 40, R radius is 40, same F 200. So this is for absolute. Then coming for incremental, for when we are going for incremental, we have to do different things. And coming to the interpolation, like if you use ijk, if you want to use ijk, I is nothing but circular interpolation for x-axis, j is nothing but circular interpolation for y-axis. So with respect to ijk, k is not there because it is z-axis. We are not revolving anything in the z-axis. So here when it has to move from a to b, so what we have to do is then we are write it as n30 G02 because it is circular interpolation. Then we have to write this coordinate, like what is the final position. Final position x is 60 and y is 70, and we have to locate the this position center. How much center is how much distance. So this center we have to take with respect to the difference. What is the difference in the x-axis? What is the difference in the y-axis? So 60 minus 20 will get as 40, and this distance from here it has to move to this position. So 40 y2 minus y1, 40 minus 30, j comes as minus 10. Okay. So from here the distance comes as 40. You are making from B to A position. B to A position is 40. This distance is 40, and from here to here, it is minus 10. Radius is from minus 10. So and from this position to this position is 40, and A position is at this position. From this position to this position it has to come minus 10. Okay. And similarly if we want to move from B to A, now we are moving from B to A, reverse if we are moving, then N for serial number counterclockwise, we are moving in counterclockwise direction. Then we have to take the x axis comes as 20 mm and y axis comes as 40 mm. Okay. So from B I am moving to from the B is this position, and from here I have to move to the x axis is 20. This because we are using as absolute, so it has to come x coordinate comes as 20, x is comes as 20, and y at this y axis is at a height of 40. At this position it is 20 comma 40. Then we have to know the ijk, and there is no difference in x-axis. X-axis is the same position, and y-axis will be at a distance of 40. Y-axis is at a distance of minus 40. So we have to take j as minus 40, and feed rate comes as 200. In tool length compensation, so what happens here is there are different kinds of uh, tool lengths. So if you see the sketch, so one tool length, so this is our uh, minimum tool length. So one is as a distance of L2, one has a distance of L3, one has a distance of L4. Suppose this is the 100 mm, so one has 85, one has 90, another has 95. So each and every tool has different length, so we have to compensate the tool length by using by calculating the distance till the tip of the tool. So whenever we placing the tool, then we have to give the value what is the total distance, what is the compensation we have to give. Suppose this is 100, this compensation is 0. So 100 minus 85, you have to insert the compensation. 100 minus 90, 10. 100 minus 95, 5. Compensation we have to enter the, and it will store in the memory data. And tool radius compensation also same thing. So this is the distance, this is the our cutting tool, and so if it's cutting this side, so this radius we have to give as a compensation. Suppose the same cutting tool is like this, then this we have to give it as the radius of the compensation. Okay, so it is based on diameter. One diameter will be 20 mm, one diameter will be 40 mm, one diameter will be 100 mm. So depend on the diameter, we have to give the cutter radius compensation. We have to insert the cutter radius compensation. Next coming candle cycle. So in the candle cycle, instead of whenever we are any repeated works are there, instead of using that one, we can use as a single in single line we can perform the different operations, and we can create a loop, and we can give the combinations like drilling, boring, reaming, tapping, etc. at a time. So this is the canned cycle of a drilling operation. So in this one, this is a home position. In the home position, it has to cut to that, it will come to that point where the operation has to perform, drilling operation has to perform. Then it will give some clearance plane. So with respect to drilling operation, x and y coordinate it will meet, but z will be, example like positive 2 mm. So this distance will be 2 mm above the drilling point. So if we give z0, then it will touch this point. So whenever we are coming at rapid approach, then we have to give a height of some our distance like 2 to 5 mm, we have to give the distance. Then this cutting operation will come out, then again we have to give some breakthrough distance, so that this cutting tool should come out of the workpiece, so that then only we can know that this workpiece has been broken. Okay, so for this one, we so for each and every point, if we use drilling, it takes so much of time. So in order to reduce the length of the programming by one third, minimum one third of the program will be reduced if you are using this uh, canned cycle operations. So first it will have rapid approach, then drill at feed rate. So it will start drilling at that feed rate, then rapid return to initial position. After drilling, it will come down, and again it will go up, and again it will go back to the original position. That is the CAD cycle operation what we follow. And coming to the next CAN cycle, there are different codes. For drilling, we use G81, for countersinking, counterboring G82, deep hole drilling G83, G84 for tapping, G85 for reaming, G86 for boring, and G86 for if you are using any multiple you are using, then we use this G84. So in this we have to write the sequence number, we have to write the which type of code we are using. If you write G81, it is CAN cycle. So xy where the coordinates are there, and we have to write the z, how much depth of the hole. Suppose we are drilling at 10 mm or 15 mm, like that we have to do. And R is the clearance position. Already we have seen at some height we have to show the position. Okay, so if you are writing the G codes can cycle, then this is the N G XY data. Z, what is the clearance, what is the how much depth has to be done, and how much is the clearance you have to keep. So compulsory they will ask one write a programming using can cycle or without using can cycle. So now we'll start the actual programming, manual part programming. So here they told that tool is of 25 mm diameter and end mill, and they have given this dimension. They just give this dimension. By using this dimension, we have to perform the operation. Okay. So this is like steps, like total is 120 by 120 square, and here we have to cut 40, 40, 40, 40. Have to cut. Okay. So in first step, we have to write the coordinates for each and every point. For this point, you have to write x and y coordinate. For this point, we have to write x and y coordinate. For this point, we have to write x and y coordinate. For this point, we have to write x and y coordinate. For this point, we have to write x and y coordinate. This point, we have to write x and y coordinate. This point, we have to write x and y coordinate. That is the first step. What we will be using in this part programming. So we have to write the part programming like 0 comma 0 120, x is 120, y is 0, 120 comma 40, 80 comma 40, 80 80 40 80 40 120, 0 120. Then you have to write all these coordinates, x coordinate, y coordinate. So it is absolute, so everything with respect to the origin. Then we'll write the actual, what are the assumption. So in the problem they told that you have to assume your own thing. So in the problem they didn't mention which tool number we have to use, whether tool 12 or tool 30, they have mentioned. So we have to assume something. So we are assuming that tool is tool 1, and speed we are considering as 1500 rpm, and feed we are considering some rpm, and codes to be used. So you have to know this code. If you want to perform this, write this manual part program, then you have to know this code. So you have to know G001 21 28 90 91 94 1, tool number 1, M03 5 6 and 30. You have to know. So what is meant by G00, rapid traverse. So it has to, from home position it has to come rapid traverse to this position. Next G01, so that it will move in linear interpolation. So it will move in this fashion, it will go in linear interpolation and again come back to original position. Next G21 is specified program done in metric units, because in India we use only metric units and not inch units, so that's the reason we have to use G21. Next G28, after the program it has to, after coming to this point, it has to go to the reference position. Like G90 we are using only absolute. Absolute is nothing but everything is with respect to the origin. So what are the calculations we have done? All the calculations are with respect to the origin only. Next, incremental. So in few cases we have to use incremental coordinate system also, from coming from home position to cutting position. We will use incremental, but when we start the cutting we use only absolute coordinate system. Like G94. So here we are given the feed in mm per minute. So we have to use compulsory G94 code. So T01, so tool number 1 is selected for our program, for our manual part programming we have selected tool number 1. Next M03, spindle is rotating in clockwise, and M05 spindle is off at the end of the program. M06, if we require any tool change we use M06, and M30 it is the end of the tape and tape is rewind. Okay, so this is the problem. You have to learn all these codes. Next we'll start the part programming. So N01, G21 and G94 will write. Next it is the home position, G91 incremental position, G28 and Z00. This is the home position what we call, and then it will come to X0 Y0. It will come at this point. Then we are changing the tool. Already we have Z at certain height. Then we are changing M06 tool change to tool number 1. So initially we assume that it has different tool number and we are changing the tool number. Then M03 spindle is on and we are assigning the speed of 1500 rpm. Then we'll start it must be go as absolute unit, and G00 it has rapid traverse, and X0 Y0 Z at height 5. So Vertical height, it is a height of 5, x0 y0 it got, but vertical height is 5. Next, z minus 1. So here we are giving a depth of minus 1 and feet of 100 mm per minute or 100 mm per minute. So next it will go to next coordinate, this coordinate. From this coordinate it will go to this coordinate 120 0 with a z of minus 1 it will move. So next it will go to 120 40, next it will go to 80 40, next it will go to 80 and 80, next it will go to 40 80, and next it will go to 40 and 120, next it will go to 0 and 120, next it will come back to 0 and 0. Then z, we are giving the height, vertical height is 0, so that it is not touching the workpiece. Next it will go to home position, the home position is x0 y0. Here we are considering, generally we will consider as x minus y y minus 5 as home position. And next spindle is stop. Next m30, m30 is nothing but program stop and tape prevent. So this is the program. Coming to next problem, so there here we have to drill a 5 holes of 12.5 mm with a feed rate. So in the previous problem they haven't mentioned speed and speed. Here they have mentioned speed as 592 rpm and feed as 100 mm per minute, and we have to use floating zero feature, and the thickness of the plate is 10 mm. So this is considered while we are making the drilling of the problem workpiece. So this is the problem they mentioned. So so this is first hole, second, third, fourth, and fifth. So it is your wish. You are considering which hole first is your wish. So one will consider 1, 2, 3, 4, and 5. Other person may consider this as 1, this is 2, this is 3, this is 4, and this is 5. It's your wish which hole you are starting to make the drill. And you know the dimension, x-axis 150 and y-axis is 125, and for each and every hole you have to write the x and y coordinate based on absolute, not incremental. Based on absolute you have to write the coordinates. So if you are writing the coordinate, so this coordinate we are taking as 25 and 25. X is 25, y is 25 for this one. And for the A hole, x is 25 and y is 100. And for B hole, x is 125 and y is 100. And for C hole, we are coming to C, x is 75 and y is 62.5. And coming to D hole, x is 25 and y is 25. Coming to E hole, x-axis comes as 125 and y-axis comes as 25. Okay. So these initial only you have to make the coordinates ready. So then assumption. So we are assuming that drill bit is at tool number 3, and we are taking the reference position as x is minus 25, y is minus 25, and z is 2 at a height of 2. So this is our reference position or home position. Okay. Next, so these are the codes we have to use: G0 rapid traverse, G01 linear interpolation, G25 it is done in metric units because in India we use only metric units, so it is metric units. G28 going to home position or reference point. G90 we are using only absolute coordinate system. G92 we are making the 0 point shift. So in the problem they told that 0 point shift. And G94 feed rate is in mm per minute, and T03 so that we are selecting the tool number 3. M03 spindle rotation in clockwise direction, M05 spindle off, M30 tape end of the tape and tape prevent. Next we will start programming. So G21 and G94 this is common for all the part programming. Next home position or floating 0. So floating 0 we are keeping as x0 y0 and z at a height of 2 mm. So at this one we are keeping the our spindle reference is minus 25 minus 25, but we are keeping the floating 0 at this origin, and we'll using the absolute coordinate system. Then actually we have started going to the spindle, going to spindle, and the tool is changing here. We are making that tool 3 is selected and spindle is started, and we are giving the speed. Then actual, so total depth we have calculated. So total thickness of the plate is 10 mm. So from, you'll suppose I will draw the 3D sketch. So this is our height and this is our plate. This is our plate. So what happens here is our uh, our cutting tool is at a height. So our cutting tool is at this height. So this distance comes as 2 mm. Example, I'm saying 2 mm is the distance, and this distance comes as 10 mm. And this drill bit has to cut and it has to come out of the workpiece, and this distance comes as 2. So total 2 plus 10 plus 2 total become as 14. So from the reference position it has to go minus 14. Then it will go, then we are given the clearance plane as 2 mm. So here we have taken a clearance as 2 mm, and bottom also we have taken clearance as 2 mm. Then actual our workpiece starts. It will go to A position. A position, A is 25 and Y is 100. Then it will go to, it will actually have drill of minus 14 with a feed of 100 mm. Next it will come back to this 2 position. At height of 2 it will come. Next it has to go to B point, which is nothing but X. Then it has gone to C point. So in the C point, X axis is 75 and Y axis is 62.5. Then after, this is the first and this is the second, where it is making the drill. And here after drill it has to go to minus 14. Then it has to go to 2. This is common for all the things. Then it is going to B, like X is 25 for B position, X is 25 and Y is 100. Then minus 14 and 2 is common for all the things. Then it is going to X is 125. For E it is going X is 125 and Y is 25. Then same thing, minus 14 and 2. Then here again it is going to the uh, origin. Then it has to go to the origin minus 25, and spindle clearance it has to go minus 25 and minus 25. Then M30 spindle is stop. Okay, then the spindle is stop. So this is the program. So here we have drill A, B, C, D and E. All the 5 holes we are drilled by using this one. Next, third problem. So coming to previous problem, in the previous problem we haven't used any can cycle. Now we have to draw the problem with can cycle and without can cycle. And if you are using the can cycle, how much it is reduced we have to draw. So without can cycle already we have drawn. So with can cycle, how much the length of the program will be reduced. Generally the program length will be reduced by 1/3 of the program length will be reduced. So G81 is the drilling can cycle, G8 is the drilling can cycle of this you have to use. So compared to previous problem, these two codes will be added newly. And part programming, so G21 and G94 it is common for all the program. And going to the reference position, G92 we are setting the home position as x0 y0 z is equal to -2, and G90 we are going absolute, and G01 we are giving the tool number as 3 and we are giving speed as 592 and M03, and then we are giving feed as 100. G81 is nothing but can cycle, drilling cycle is on, and X is 25, Y 25. So X is 25, Y 25. We are going at this point position, and minus we are directly given the clearances minus 14, and clearance plane is 2. Then Y, then X is same. We are just giving the Y distance. Then we are drilling this one because X has no change. X is 25 for this one also. So that just we are entering only the Y. So Y we are entering. So here we are given minus 14 and clearance as 2. So automatically it will take automatically. Then we have to go to 75 and 62.5 because X changed, Y changed. Here also X changed, Y changed. Then here X is same for B and E. X is same, only Y change, so only Y 25 mm, Y 25 mm we have taken. Then G80 nothing but can cycle is off, and M05 spindle is stop, and we are going to spindle clearance point. And M30 spindle is exactly spindle is stop. Then the program is completed. M30 compulsory at the end you have to write M30. Okay, so this is the program using the can cycle. Next, fourth problem. So we have to write for step turning. So initially we have seen only for building problems. Now we will see the turning problems. So here the spindle speed is of 1000 rpm, and feed rate we are considering it as 30 per minute. Okay, and we have to assume any suitable parameters if required. So first we have to see the sketch, what the sketch is. So this is a sketch. So here we are making the step turning. So first diameter comes as 10 second diameter comes as 14 third diameter comes as 20 and length L1 is 15, L2 is 15, and L3 is 20. And if you know, if you check the coordinates, this is my x coordinate and this is my z coordinate. Already we discussed what are the coordinates we use for turning machine earlier, and this only we have to use x and y. This is not x and this is not y. Don't confuse. For turning, this will be the z and this will be the x axis. Why it is x and y? We have learned the what is the coordinate system for the lathe machine. So here we have to take one more dimension called u and v. U is a substitute of x, v is nothing but y, and w is nothing but z. So here x is 0 and z is 0 in this point. Okay, and from here we are taking a positive x. So here we are taking a positive x, and here this is positive x, this is negative x, and from here it is negative z. If you are going backside, negative z. If you are going from here, it is positive z. So here x-axis is nothing but, in general terms, it is y-axis. Z-axis is nothing but, in general term, it is x-axis. But in turning, it will be totally different. So we are writing, in order to avoid confusion, we are using u and v so that our value is correct. So G21 and G98, this is the common for all the program. Next, U0, W0. So our cutting tool has to come to U0, W0. Then we are changing the tool, and we are changing the tool to tool number 2. Then spindle is on, and we are giving a speed of 1000 rpm. Then X20, Z1. So X20 and Z is 1. So 20 is at this point. So our point is at this position, and z is -1. So it is outside. One thing, it is outside. Next, x is 20, z is -30. So this direction it has to move -30, and from here to here, it has to move a height of 20. It has to move a height of 20. From here to here, it has to move a height of 20. From here to here, it is -30. Z is -30. Z is nothing but this axis. This axis is -30, and this axis is 20. And feed is, we are given the feed as 30. Then it has to, after this one, it will come down, and 19 it will go. Then 18. Then 16. Then comes as 14. It will 4. When it will go to 14, we have to know this coordinates. Okay. Then 17, 16, 15, 14. Then this coordinate, so this is the vertical height. So the vertical height comes as 14. This comes as 14, and z is nothing but same value. So z is minus till here. It has to go till the end. 14 also it has to go till the end. Then this distance, it will go till here only. This distance is comes as 15, -15. Okay. So x is 13, z is -15. Then 12, 11, because there is no change in z value. Z value is same. Only x value is changing. Only the changed value we are taking. So it has to go till this point. Till this point. Then at a height of diameter, vertical height of 10, it will be closed. So at the end, Z0 rapid traverse and Z1. It will. This is Z0. It is coming Z1 outside. then u0 w0, it will again come to this position u0 w0, then m00, it will go to m00. So that is the okay. So this is the explanation of the problem. So fifth problem, same thing we have to use with the, in this problem we have to use with can cycle and without can cycle. The problem I have taken directly from the textbook. So first we have tried the coordinates. What is the x coordinate, y coordinate, what is the x coordinate, and what is the y coordinate, what is the x coordinate, and what is the y coordinate. So here they have told that this total height is 15 and we are taking clearance at 1 or 2 mm. We are taking the clearance and it is a square block of 100 comma 100. Come 18, again it will come above. Okay. So next coordinates is 55, x is 55 and y is 50. So minus 18, then again it will z clearance plane 2, and next 75 and 70. So x axis 70, y axis 70, 75 70, then minus 18 clearance plane, and x0 y0 z50. So it will go to home position. Home position is at a height of 50. Now if you are using a can cycle, it will be reduced to 1 by third. So in a single line only we are mentioning G81. G81 is nothing but drilling cycle on, and directly we are giving coordinates x coordinate, y coordinate, and z. We are maintaining as we have to go a depth of 18 mm by keeping a clearance plane of 2 mm and feed as 125. Then it will go to next position 55 and 50. It will go to the next position 75 and 70. Then x0 y0, it will go to home position. Then your problem is completed. So if you're using can cycle, only 4 blocks is required. If you're not using can cycle, then 100 blocks are required. Okay. Next, parametric programming. So instead of writing the 15 programs lines, we can write only one program and we can call that program continuously again and again. Then that is called as the parametric programming. So here different size we can use, like outer diameter, inner diameter, thickness. For everything we can use. For any material we can use, like low carbon steel, high carbon steel, stainless, any grade, bronze, brass, aluminum, anything, any polymer we can use this parametric programming. Just we have to assign the table of assignments. So in this one we can use like different programming language like basics, C language, Pascal, etc. And we can access the G code in this parametric programming by assigning the parametric values. So here we can use the custom macro B in the phonic CNC machine. We can use this one, or else we can use the phonic compactable controls, and we can also use the Q routine from SolidX and advanced programming APL and GN from GNL. We can use these kind of programming by using this in this parametric programming. Okay. So parametric programming example. So here we'll write the program number, then we'll give the what is the diameter, tool diameter we are taking, then what is the x position, what is the y position, how much depth we have to go, and how much the speed we have to take, and how much the feed rate we have to take. In next in the tool length offset, how much tool length offset we have to take, how, because we have to give the compensation for tool length and what is the diameter of counter board. So after drilling we have to make the boring, then we'll select the which board, absolute mode, and we selecting the coordinate system, and we are clicking the start spindle, then wrap it to hole center. Then we are using the tool length composition and rapid approach in this code, in this programming. Then directly we'll go to end of the programming, M30, directly will give end of the programming. So everything will be right in the parametric programming by using these different programming languages. Okay. So this is the end of the manual part programming in the CNC terminology.